What is the first best renewable energy? You know the answers because you went to that other one, yeah? Yeah.
Solar? No.
It is the energy that we don't use.
Oh.
The first best is the energy we don't use. It's energy conservation.
Wow.
And so reducing the amount of energy. So everything that I've done in my house is to reduce energy use first. I don't have solar panels on my roof because I have a lot of trees. So the second best thing is to have trees. Because the trees and the environment, I know not in your case, but in my case, they help shade my house in the summer, which reduces my heat or my cooling load. They provide protection and they make their own microclimate. Your landscaping can make your own little microclimate around your house. So by the way it's oriented and the way it's landscaped, it can help protect your house in the wintertime from really cold. So that helps as well. And here's the second question, and it's for you too. These people all know the answer.
No, I don't.
And you may know this because you were talking to me about this. So the difference between passive solar and active solar.
Sure.
Passive is just taking the orientation of your house and on the south side and getting the sun into your house and using thermal mass to hold it in your house. Thermal mass to hold it in your house, or having extra insulation or whatever you have to help hold that heat in your house. Just as getting the sun in your windows. That's all it is, an orientation of your house. So what else there is to talk about outside? So the orientation of your house is pretty darn critical. So as you can see, this is south. This is directly south. My house is a little bit southwest, and we had to do that because of the street and the lot lines. So we had to line it up with the lot lines because I have a very shallow lot. Nobody else wanted this lot because it was only 120 feet deep, but 120 feet deep isn't much because Weatherby Lake has setbacks that they have 50 foot from the front and 40 foot from the back. So you take 90 out of 120 feet, you've only got 30 feet of depth to get your house into. But that was perfect for a passive solar house because you stretch it east to west, make it really long so you get the windows, and so you're getting the south sun in the wintertime. And so that's why it's oriented this way. That's why this lot was good. I had the big trees to work with to help shade in the summertime. So all that contributed to this being a really good lot. And that's the first, like I used to work with a company that built houses new, and I worked with the clients, and that was the first thing we talked about, is choosing a good lot so that your orientation was correct for your house. So, and even if you're buying a house in a subdivision, if you look for a house that's like yours, the front is facing north and the back is facing to the south so that you can have more windows in the south and get that sun in.
Yeah.
So.
I do have a lot of windows.
Yeah. So, and a lot of people wouldn't have wanted this either because if this was a normal lot and didn't have these trees and didn't have this berm, this is a natural, well, not a natural berm, it was probably a berm that was created when they built this road. But they built this road in 1937.
Wow.
So by the time I got here, this berm that they created from cutting this road, the trees had already gotten big. So it was perfect for me. That berm elevates the vegetation, which makes it so and the road is down a little bit, so you can't really see into our house, which gives privacy. So it was a perfect lot for me for what I wanted to do. And having the windows face, normally you would be pretty exposed if you had your windows facing south toward the street, and you would feel like you were in a fishbowl. But not so the case with my house, so it was really good.
So the other thing about active solar is that it uses some mechanism to move the heat, pumps or fans or something like that.
Right.
That's active solar.
So at one time I had solar hot water. So this house is 16.
You have a solar panel.
I have a solar. Do you want to? You can come back here, Marilyn. You can see it. But then I'll explain what happened. This is a solar hot water panel.
Okay.
And I used to generate hot water, and I had a Ream solar hot water tank. And the Ream solar hot water tank was guaranteed for 10 years. And what happened in the 11th year?
It gave out.
It gave out. And so because the Ream solar tank was so expensive to replace, and it was expensive, and nobody around here HVAC wise wanted to hook it up, wanted to mess with it because it came from the company that I used to work for. It was designed by the president of this company, and he knows how to do it. So I asked him if he'd come and install a new one. He says, he gave me a price, and he says, it's going to be really pricey. It's going to be, for me to come up there and install a new tank, it's going to be $5,500.
Oh.
Because a new tank was at $3,000 at that point.
Oh my God.
This tank. This ream tank, because it's got all the copper coils in the bottom to transfer the. It's copper. There's copper in the solar panel, and it transfers the heat down to the solar tank. But anyway, so he said a more reasonable thing to do, because now 16 years later we have heat pump water heaters available.
That's electric.
It's electric, but it runs just like a heat pump. It pulls the heat from the air surrounding it and heats your water. So it's pretty efficient, and it was only about $1,200 as opposed to $5,500.
Yeah.
So I'll show you that.
That's a big difference.
That's a big difference. So
And what's the warranty on that?
I don't know. It's probably 10 years. It's probably 10 years. Yeah. But anyway.
Save up for the next.
Yeah. So my house is all about the orientation. It's getting the sun in the windows. You'll see I have some thermal mass, and I'll talk about that on the inside. I also have 2-foot overhangs that are sized to keep out the sun in the summertime.
Oh.
So when we built this house, there's ways you can calculate the sun angles, so that as the sun goes up high, you'd give it an angle that's up high in the sky. So you design the depth of your overhangs to completely shade your windows down to the bottom during the summer, and as the sun comes down in the sky, then it moves up the windows. So as fall is coming and you want some heat in the house from the sun, you can get it. You can want it in the spring, you can get it. Like today.
Yeah.
So the sun will be coming in
And
today.
all winter
I
long.
have old wooden leaky kind of windows, but they let in a lot of heat in the winter from the windows,
Yeah.
which has been a hesitation for me in terms of replacing them, because the replacement windows are so insulated. I'm afraid it wouldn't let any.
They've got ways to deal with that. So
Okay.
I have low E glass windows, and what they do, they have coatings on them that let the sun come in the wintertime, but they reflect it back out in the summertime.
That's a low E. That's what
Low E
is.
glass.
You use that on the south window.
And we use that on all the windows, actually. Just different solar gain coefficient.
Yeah, solar heat gain coefficient.
Yeah,
You want a high SHGC, which allows the solar heat to come into the window.
So the front
So
side of my
you
house
just
has
have to tell them what the glass
yeah,
needs
you
to
have to
be
tell them the
used for.
orientation of your glass. So if it's in the south, you get a glass put in your windows that is a higher solar heat gain.
Okay.
And then there's a lower solar heat gain on the other windows. It keeps more heat in.
Especially on the west. You want a low solar heat gain.
Yeah, especially for the west. But you see my trees in the west?
Yep.
That's the other thing.
Yeah.
Yeah. But I probably do have the lower ones on the west as well. So because we do after you lose the leaves, you do get some sun in there. So, but sometimes in the winter and the fall you want it. So. Anyway, okay, so it's
I'm
orientation.
glad you're recording that.
There's a lot of
I'm not
information.
taking notes, so it'll
Yeah.
be helpful to listen to. Like,
Yep. Orientation, landscaping, trees, overhangs. And then I have one other thing to point out here before we go inside. See the ridge vents that are all like this right now? That is in something called, it's a ridge vent, and all my ridges have that vent on them because it is part of a system called an ice house roof that keeps the heat from building up in your attic, and it puts it in this space, and I'll talk a little bit more about it later, but it puts it in a space that I have continuous soffit vents, and then I have the continuous ridge vents. So it pulls in the summertime when your roof is heating up, and normally that heat just filters down into your attic.
Yeah.
The way my attic is designed, it's something called a non-vented attic. So I don't have vents in it, and I have spray foam insulation, and I'll show you a piece of spray foam too. But so there's a piece of cardboard that is stapled underneath my rafters, down about this far, and it creates a 2-inch gap that it pulls the cool air, or pulls the air from under the eaves, and it takes it in that channel out to the roof vents. It keeps it from coming down into the attic. It also has a radiant barrier on it, but reflects it back up. So the hotter it is, the faster that air moves and takes it out of that space. Yeah, but it can be done. It kind of depends. Orlo gave us, the president of the company that I worked for, he gave us a presentation. And he said, if you have trusses, which I have trusses, attic trusses, it's very easy to do. If you have rafters and they've had to put blocking in your rafters to keep them stable, to keep them spaced, it's not so easy to do because you're using that rafter space as a chase to take it out the roof vent. So it kind of depends on the construction of your attic.
Yeah.
If you wanted to add it. So. But anyway, so my non-vented attic, I don't have any vents up there. And then underneath that ice house roof where they've got the radiant barrier that reflects the heat back up, I've got this much spray foam sprayed on the underneath side of it.
Okay.
So it's instead of on the ceiling of my attic, it's up underneath the slope. And that makes my attic space very comfortable. It's within just not too many degrees of the rest of my house.
Wow.
And so it's this big space, this dead air space, helps insulate too. And it helps keep the heat from coming down into your house and your air conditioning having to deal with it in the summertime.
Okay.
So yeah, because this is a passive solar house and my windows are all lined up, but you have to be careful about how you size the windows and how much sun you let come in those windows. Because I built a house in Lewisburg, it was a passive solar house again, but I didn't have overhangs. I was designing some houses, but I wasn't working for this company yet. So I didn't know about the overhangs and getting them sized properly so they kept the sun out in the summertime. And we had a big problem with overheating. And even we also didn't have, at that time that I built, we didn't have low E glass. They developed that just after we built our house. So I just had regular, I don't know what I had double pane windows, and they were Pella windows. They were the good windows, but they weren't low E glass. And I didn't have much thermal mass. I had tile floors, but I didn't have much thermal mass to go with those tile floors. And so even in the middle of winter, it'd be 20 degrees outside, but it'd be 85 in our house. Wow. Because I had too many south-facing windows, not enough overhangs, and not enough thermal mass. So you have to be really careful how you balance that. Yeah. There's equations to use and all that sort of stuff. So we were careful not to put too many windows, and then we were careful because I do not have a basement and I do not have an attic, because I've got that unvented attic is my buffer zone, but I do have my thermal mass as my floor. I have 4 or 5 inches of concrete underneath this. So this is a concrete floor. As you can see, it has got a crack here and there. The crack's no big deal. They did that as soon as they poured it, before they even stained it. So this has got a stain on it.
Okay, this is...
Yeah, it's stained and cut. Yeah, and you'll see, when you go around and look at the rest of the house, you'll see after 16 years there are places that it's wearing a little bit where we walk a lot more, or in our shower especially, because we have a walk-in shower for my husband. He's in a wheelchair. This is my husband, Mike. And so we can roll him right into the shower and stuff, and you'll see in the shower the stain is all worn off in there, but that's okay. It's all right. I said I would expect that after 16 years of scrubbing it down and all that sort of stuff.
And they could be restained.
And they can be restained, yes, and refinished. So I have thermal mass, no basement, no attic. I have my unvented attic. My house is built like a styrofoam cooler. That is the other thing. So my previous boss, he uses this analogy for you to think about how a house is built versus the airflow and how you keep the heat in, or what heat escapes. Heat always wants to go where it's cooler. So whatever you have, it always wants to go to wherever it's cooler. So in the wintertime, when I'm taking the sun coming in those windows, when the leaves fall and comes in, it comes into about here. So it comes in a long ways. But it doesn't have to hit the concrete for it to work, because it heats up the air, the concrete is colder, the concrete pulls the excess heat out of the air, keeps the house at a very comfortable temperature, and stores that heat in the concrete until it starts cooling off. When the house starts cooling off, it pulls that excess heat out of the thermal mass and keeps, so sometimes even in the middle of winter, our heating system might not come on until 10 o'clock at night. because the heat that we've stored during the day comes up and heats the house in the evening.
Could you have a concrete floor if you have a basement underneath?
You could, but it's very expensive.
Okay.
Because they have to they have to support it because it's very heavy, so they'd have to put in a lot of extra support down
You
underneath.
have heavier truss and maybe more
Heavy, yeah,
supports.
yeah. So it would be difficult. But if you built a sunroom on the back of your house, it could definitely have a concrete floor to store that heat.
Did you have a reason for not doing a basement on this lot?
Yes, I do have a reason for not doing a basement on this lot. We're on a rock shelf. The people right to the east of me, they raised up their house to deal with the rock, so they didn't have to blast it out. The people that live back here did the same thing. They raised up their house so they didn't have to blast out the rock. I decided because I wanted the slab, I wanted the thermal mass. That's the other reason it was a perfect lot for me. Because somebody else, if they'd want a basement, they would have had to blast out a lot of rock. So I am on a rock
That
shelf.
adds to your thermal mass too.
It adds to my thermal mass, I'm sure.
Underneath there, yeah.
So, yeah, because they tied my footings right into some of those,
Yeah.
And they actually had, this is limestone, of course, and they had little caves. He got down, not at that end of the house, it was very stable, but starting about my office door this way, the builder was finding little caves in the limestone, little holes, and he would drop a plumb bob down there, and he said, it's not ending. He says, I think we better have a soil engineer in here. So we brought a soil engineer, and he says, you need to fill these little caves with what's called flowable concrete. So we brought in some concrete trucks with this flowable concrete, and they pumped it all down in these holes down at this end of the house to make it more stable. So
You've got a lot of thermal mass.
yes, I have a lot of thermal mass.
Fascinating.
So that's good. But I said this house is built like a cooler, so I started to explain that analogy. So Orlo says, and he's the author of this book, Holistic Green Homes, which you are welcome to take and keep, because it has a lot of info in it. But he uses this analogy, which I love, to explain to people how a well-sealed house works really well. Is because imagine you are in a jet going someplace, and you are up at 35,000 feet, and you know what the wind speed is, and it's very cold outside, but you're not cold inside the plane. But you're not cold inside the plane because the plane is sealed really tightly. You've only got this much insulation between you and the outside of that plane. You're sitting by the window. Yeah, that plane skin is only about like that, and that's all the insulation that's in there. So when you're leaning against the window, it feels cold when you're flying. But the reason that you can survive in that plane is because they've sealed it up and they can condition that air. So it's sort of the same thing with a house. This house is really well sealed. It's very tight. It's insulated all the way around with spray foam or insulated concrete forms. And I'll pull out an insulated concrete form if you'll remind me, because you could use that in the sunroom too. But the insulated concrete form is used to make a foundation. So this is what insulated concrete forms look like.
Okay.
And so they use that to build the foundation wall. So it's all insulated. Styrofoam on either side, they pour the concrete down the middle. So your foundation is insulated because you lose a lot of heat through a foundation. So you think about that concrete and the cold being out here, it migrates right through that concrete. Another guy that he has a thermal camera, and he came to my house once with his thermal camera. Well, he did his own house first. In the middle of winter, it was a 20-degree day. He did it on the same day. He had a place in his basement, a corner, where he shot a thermal camera, imaging camera, and it came back at 48 degrees in his basement. They brought the same thermal imaging camera to my house the same morning, and he went around to my house, and the coldest place that he could find, any place in my entire house, was up in that corner, and it was about 67 degrees, I think. Wow. That was the coldest place he found in my house. He says, I want to see where your heat pipes are. And I said, they've shut off, because he came at about 10:30 in the morning, and I have radiant floor heat too. So he was wanting to see if he could see where the pipes were in my floor, and I said, I don't think you'll see them, because probably this shut off about an hour and a half or 2 hours ago, because the sun was coming in the windows by then, and it shuts off, and the heat dissipates on the floor. So he couldn't see where the pipes were.
And this looks like there's spaces in between, like a fence, like it's not solid, is that right?
No,
Or
it is
those
solid.
Are just marks.
These are little plastic ribs that go. I'll show you.
Oh, okay.
I'll show you the real thing.
Okay.
And it's actually so you can screw siding and things to it.
Okay.
So
okay.
those are every 8 inches apart.
Okay.
But anyway,
Interesting.
so my house is sealed up really well. Not only does it have styrofoam, it has styrofoam. It has spray foam on the slope. I have spray foam in the sidewalls, and I have a special wall construction too. But spray foam in the sidewalls. The slab is actually, I've got an insulation blanket underneath the slab, and then my insulated concrete forms. So it's insulated all the way around. So it's like a styrofoam cooler, basically. And then it's sealed up. So everything that normally you would have a builder come and they would like stuff the little pink fiberglass in the sides of the windows. When they're installing windows, this is what they used to do. They used to take fiberglass and use a knife and they poke it in all the holes around your window to keep it from leaking. But that's not what fiberglass, it's not how it works best because it's all compressed. So it doesn't do its job. It just stuffs the hole, but it still leaks. The air will still go through it. So around windows and doors, they have a special spray foam that you can use that it goes in that expands, but it doesn't expand so much that it negates the warranties of your windows and doors. So, but it seals it up a lot better. So, and then every other place that that you would have going up into your attic, which is a huge amount of space, in most people's houses, it's like a hole in the wall about 3 feet by 3 feet. It's like if you took all the places that are leaking in your house around windows, doors, outlets, can lights, anything like that, there's about a 3 by 3 hole. It's like cutting it right in the side of your house all the time.
It's like not having that window in.
Yeah. They're energy raiders. This is Charlotte. That's Ken. They came and I wanted them to repeat a blower door test on my house. So do you know what a blower door test is? So they have a video over here and you can see it. We did a video a few weeks ago so that people could see what a blower door test was. It's very important. It identifies all the places in your house that are leaking. So they can go around, they put a big fan in a door, they close all your windows and doors, they put a big fan in your door and they pressurize it. So it's like a big 20-mile-an-hour wind hitting your house on all different sides. So it accentuates any leakage areas that you have so that you can identify them and do something about them. That's what the greatest thing about a blower door test is. So they did a couple of blower door tests on my house, one during construction after they did the insulation to see if they missed any places of insulation, and they did. Because you can walk around with a smoke stick or a special thing that does smoke, and every place that it goes like that, you know you've got a big air leak because it's sucking the air into the house. So yes, we had to call back the spray foam insulation people because they missed getting a place that's from my garage that went underneath my stairs and would have been an air leakage place if they hadn't come back and done it. So we could catch it then. Then they did one when the house was finished, when after the drywall was all on and it was all finished. Then Ken came back and he did another blower door test, and it was great. And my house is very little leakage, so I have like if you took the leakage in my house and put it all together, it's about like that much, as opposed to 3 feet by 3 feet. So I still have a little bit of air leakage. But when Ken and Charlotte came back a couple weeks ago and did it again, I wanted to see after 16 years how the house was performing, if I still had any. If I had any leaks or developed any things or any insulation had come down or anything like that. And greatly, I found that it had not. It was doing pretty darn good. We went around and checked some windows, we checked some doors. The biggest place that I had were doors, and it was where the molding, the weather stripping, it was where the weather stripping around my doors was wearing out. So I have a few places around my doors that I need to replace weather stripping, but that was what was leaking. So they check for, when they pressurize the house, they'll give you a reading like for natural air changes per hour. And my natural air changes per hour when this house was first built is a figure called 0.09. Very little air leakage. When they did it a second time, it was 0.11. And that was the result of my air leakage around my weather stripping that was going bad. So other than that, we didn't find any windows that leaked. We didn't find anything else that leaked.
What would it normally be, like a normal house that you would look at?
Normally, the leakage in the Kansas City area, it's about 0.5 to 0.6. So 50 to 60% of your air changes out every hour.
It's like having that window open.
Yeah, exactly. It's
So
just
is
like
that
having
something-
that window wide open all day long.
Which means you heat it or cool it depending on the season.
Yep.
So this is all part of reducing your energy use.
Yes.
So when people, so I'm going to give a talk at Mark in a few weeks,
Oh.
and because they called me and asked HRES to give them a talk about solar. And I'm going, well, we're not really experts on solar particularly, but we are kind of experts on, we have more expertise in telling you how to prepare for solar, how to reduce the energy usage of your house before you spend the money, because you won't need to spend as much money on solar if you've reduced the energy use of your house. Yeah. Listen to this. Let's see. Let me get my glasses real quick. This was.
Solar doesn't work very well at night.
Oh, come on. That's where that's.
It does if you store it during
It's
the
stored
day.
in the ground. It's stored in our floor. So the Solar Today magazine that came out just recently, there's a man in here that he is a senior fellow at the Post Carbon Institute, and he wrote in this article. I read this whole article, and this is what stuck out to me. He said the real energy transition will almost certainly not be a complete and seamless migration from fossil fuels to solar and wind, but rather a shift from using a lot of energy to using a lot less energy. I thought that was really interesting. So yeah, I've got a lot of insulation. I have some special wall construction, which I won't try to go into, but and I have a low E glass window. I don't have the most expensive windows. I've got I don't have a Pella or a Thermit, Anderson window, or I don't have one of the more expensive ones. It's a lesser known company in Kansas City, but they make a very good window.
What's the name of it?
It was called Allside. I don't even know if they're still in business, but Allside. But they might still be. I haven't even looked recently to see if they're there. And I have Therma-Tru doors, which are insulated. Therma-Tru doors. They are insulated. They're fiberglass, insulated, and they also have low E glass in them.
So were your windows wood, fiberglass,
They are not. They are vinyl.
or vinyl?
They're vinyl
Okay.
windows.
But
You
they've held up.
They've held up just fine. So I see all those commercials on TV where they're poo-pooing vinyl, and they say they're leaky, bendy, misshapen windows, and I'm going, well, mine after 16 years are doing great. So it must have been a pretty good
By
window.
Anderson commercials. I think
Yeah.
they're super expensive.
Yeah,
Yeah.
yeah. So I'm real happy with these windows because they weren't the most expensive. So, what else haven't I told you about?
So you have hot water heat in your floor?
I do have hot water heat in my floor. George asked if I have hot water heat. So
Is that gas?
it is gas. I use a tankless gas-fired unit to do the floors. But I will tell you, I use it the least possibly that I can, and they are not on yet by any means. I use my heat pump. I have a heat pump. We're talking about the HVAC stuff. So my heat pump is an air-to-air heat pump. It's not a ground source, so it's not the most expensive. But air-to-air, it works well because my house is sealed up well. If you try to put it in a leaky house, you're not very comfortable using an air-to-air heat exchanger. So, because a well-known HVAC guy in Kansas City, longtime HVAC guy, I contacted him. I had a client this spring over in the Nationals, and his house was only 4.5 years old, and he wanted to be off gas. He said, I'm going to have the gas company disconnect my gas connection. I'm going to have all electricity, and I want to use a heat pump, but I don't want to pay for a ground source. So I asked Eric if he would recommend that, and he said, nope, it's a 4.5-year-old leaky house. It's a leaky house. And so we had him do a blower door test, and yeah, his house was fairly leaky. He didn't have enough insulation in it. And I told the guy, Eric told him, he says, you are not going to be comfortable this winter. He says, well, I'm going to do it anyway. Because he didn't want to pay the money for a ground source one, so he did an air-to-air. But he also did some air sealing. He had a company in, and we sucked all the fiberglass insulation out of his attic. We sucked it all out, replaced it. We went back in and did spray foam on his attic floor, a couple of inches of spray foam. So he sealed up around all his penetrations that went up into the attic because he did have a vented attic. So we did that, and then we came back in with some cellulose, about that much cellulose, and sprayed that in on top of that. So his insulation in the attic will be much better. We went in the basement and we insulated with 2-inch styrofoam all his exposed concrete walls so that they would not transfer the cold in the wintertime to the basement. Everything that we could still access, we did that too. And they came in and they did spray foam in an area called a rim joist, which we did at George's house. George did that. So the rim joist area is the place between, here's your top of your foundation wall, and here is your truss or your joist sitting on top of that. Well, in this space right in here where your joist goes out to the edge of your house, there's a really good leakage place right there for cold air to come in. So you go and put the spray foam in that, and he did that. So everything that we could access, he did. He tweaked some vents, he added some vents, he added an energy recovery ventilator, which I'll talk about a little bit later too. I was trying to think if we did anything else. But anyway, he repeated the blower door test. Just those few things that we did, it improved the natural air changes by 50%.
Wow. So
just those few things. So you can imagine if he built the house better to begin with.
yeah.
So I'm keeping in touch with him. I want to see how he does this winter, how comfortable he feels or uncomfortable he feels, because he doesn't have any backup. So
Does he use resistant heat backup?
yes, he has resistant heat backup in his heat pump.
His first
Yes.
thing. That's the system I had first.
Well, and my heat pump uses that too. But frankly, what happens, my resistance heat never kicks in because I've got my radiant floors.
Yeah.
So I've got my thermostats all adjusted so that it's really interesting how this all works. During the day, when the temperature gets above freezing, the heat pump works really well. And the sun coming in the windows. Between the air circulation of the heat pump and the sun coming in the windows keeps our house super comfortable. When the temperature drops below 32, it starts staying in the 20s or whatever. During the day, I turn on the floors because Mike gets cold. So
It's my fault.
it's his fault. I turn on the floors. And I said, is it time to turn on the floors? Yes, I'm feeling cold. It's time to turn on the floors. And I usually run the floors like in December, January, February, sometimes only halfway through March, sometimes all the way through March, depending on how cold it is. You know, like last year, it stayed in the 40s like till mid-April.
Yeah.
And so I even had them on for a bit. But what happens is during the night, I set my heat pump thermostat to go down, let the house cool off. The house cools off to the temperature that I set the floors at. The floors kick in during the night. Then the floors turn off during the day when the slab is warm. They turn off and the heat pump takes over and the sun takes over again. So I've got this down to where I'm using it as little as possible and using the one that's most efficient at the time.
What would be your average utility bill then?
My average electric bill has averaged for the past 16 years between $100 and $120 a month for everything. So, and I pay a little more for the gas in the 4 months that I run the gas, so I got to pay that extra. But other than that, I've been really happy with the way my utility bills have stayed very constant. It goes
What's a square footage on this?
1,600 on this level. I've got an upstairs that has another 740 square feet.
Okay.
So, but I'm really happy with.
Decent size house.
It's a decent sized house. Yeah, that's the other thing. When we go see Vic's house, which his house is next, we're going to go see his. When I design houses for people, that's the first thing that I talk to them about reducing your footprint, reducing the amount of square footage that you have to deal with, because that's going to reduce the amount of HVAC that you have to have and reduce everything. So it's not as expensive when you have a lower footprint size. So yeah.
Yeah, but where are you going to grow your vegetables?
And you're going to grow your vegetables right in your living room too, even if it's smaller. Vic might take it up. He's got a spare bedroom. He might have to dig.
The hydroponic.
Yeah.
Yeah, right.
Or we had a video about growing with LED lights, a certain color of LED lights, and just grow in your house. You can keep these lights on a certain length of time of day, and you can grow all kinds of veggies in there. So
I've been doing that ever since that presentation.
have you? Yeah.
I've got it's addictive.
It's addictive?
You get started with it, you just yeah.
So this example that you used, someone who'd already built their house, but then you came in and changed it in terms of energy usage. How much did it cost to do that?
It was a lot.
Some idea.
It was a lot. I'd have to ask him. I was trying to remember. As you just was starting to go that direction, I was starting to try to remember what he told me it cost him. It was a bunch because the heat pump was expensive to begin with. He also insulated some duct work. He put in this energy recovery ventilator that I'll talk about. And those are about $2,000, $2,500 to install. I bet he spent $30,000. Yeah, with everything.
Is that all?
Is that all? Well, you know. And then he thought he was doing this in anticipation that he would add solar panels, but he wanted to do this first and get his energy use down. So he's waiting through this winter to see how he does. It'll be interesting. So. But I talked about an energy recovery ventilator. That is, it's short. It's ERV for short, and because you seal up a house, so like at the airplane, they seal up that airplane really well. They have to pump in fresh air, bring in, do the air changes. But instead of doing it naturally, like having a window open, you do it mechanically when you have to have everything closed up. So when everything is sealed up really well, you have to install this piece of equipment. I told this guy, Stephen was his name, I said, you go ahead and do the sealing, but I really would like you to install an energy recovery ventilator just to make sure that you don't have radon gases building up in the house, you don't have any other, like I have a gas cooktop, so that's my only gas appliance except the floors, and that's out in that unit is out in my garage. But anyway, so to keep from carbon monoxide buildup in your house, bad odors, all those things. I have an energy recovery ventilator that runs, right now it runs for 20 minutes out of every hour. Charlotte said I ought to be running it a little bit longer because of its rating, but it has been a really good thing. What it does is it pulls fresh air from outside, it brings it into this box, and I'll show it to you in the garage. It exchanges whatever the temperature is in that air. So if it's in the heating season, it's cold air that's coming in, but you're taking I've got vents, so this is, you can't see it. This is one of my ERV vents. It's right here in the kitchen.
Okay.
I have one in the kitchen, I have one in every bathroom. And that takes stale air out of the house, and it takes it, and then so if you've already preheated that air, like in the wintertime, it goes through that box, it exchanges with the cold air coming in, and that preheats that cool air coming in. So when it comes into the house, instead of being 20 degrees, it's probably closer to 65 degrees. Works the same mine's an energy recovery ventilator, not a heat recovery ventilator, and it works in both seasons. So as the hot air is coming in the summertime, the cool air we've already cooled is cooling down that air before it hits the house. And it just dumps into my house. I'll show you where that is too. But so the three vents take it out and the fresh air comes in. So I'm always changing my air when my windows are shut. So, yeah.
I remember during the pandemic there was a restaurant on the plaza that said they switched to that to help ease people's mind in terms of
Getting COVID, yeah. Yeah. So it's always good to be changing your air, so especially if your houses are sealed up. So
You can put a UV light on them if you want to add some sanitation.
But Charlotte says that the builders building today will build just to the edge of their, so they don't have to install one. They'll insulate their house and seal it just enough, but not so much that they have to install one of the energy recovery ventilators. They don't want to put out more money, yeah. Yeah.
Well, that's why we have codes to force them to do stuff.
Well, that's what the code in the Kansas City area is. If you have to be less than 5 air changes per hour at 50 pascals of pressure. So when you have the house real pressurized, the air can't change out more than 5 times. And if you get below 3, you have to put in fresh air mechanical ventilation. So the houses in Kansas City are built between 3 and 5 air changes per hour. They don't go below 3 because they don't want to have that extra expense.
But if the consumer really knew what the value was, they might very well prefer
Yeah,
that.
Yeah.
they'd say, no, I want it to get down,
It's like if
Let's get it down to 1 and put in a ventilation system.
they sealed you up in that airplane and didn't give you any air, yeah, it's kind of the
Yeah.
same thing.
Well, and it's gonna, the 3 air changes is still gonna be changing the air, but your fresh air is going to be coming from your rim joist, which is down there with the wet ground with
And
all the
sometimes
mold
mold.
spores, and so you're bringing in not so fresh air, because of the leakage in the house. So you want to seal it up and know where your fresh air is coming from.
And then this is a metal thing
No,
behind
I think you can wait another 15 or 20 minutes.
Well, that should just reflect
Just
the
a
heat,
reflective heat.
isn't it? That protects the wall. and
Yes,
reflects
from the heat.
Yeah.
That was required to install it. And there's another panel back there that's cement. It's a cement panel behind that, which then stands out from the wall to protect that wall from the heat from the wood stove, even though that wood stove has a shield on the back as well.
And it doesn't get used very much.
Well, and we do use it when I had it because I wanted to diversify for when the electricity goes out. That will heat the entire house. It will. I mean, it puts out enough heat that it can, and I can also cook on it. That little hot plate on the top, I can heat water. I can heat soup. Yeah, I can do stuff if
That's
it.
your backup.
That's my backup if the power's out.
Resilience.
Yes,
It
That's-
feeds a campfire right where you're sitting.
pizza
You
campfire.
can do that on concrete.
Yeah, I know. Might make a mess with them though. A mess with
Kind
them.
of
Yeah.
hard on the ceiling too.
Yeah, I try to diversify stuff, and that's why I have multiple systems. So that's why I have a gas backup. You know, if the gas prices go up, I don't use it so much. Or maybe I use the heat pump more, or maybe I use the wood stove a little more. You know.
Okay.
You have any other questions?
You going to show the rest of the house?
Yeah.
Or should we turn on the...
You're welcome to look at the rest of the house, and I'll answer any questions. I'll take you out to the garage after you look.
This book.
Yep, you're welcome to take that book. Okay. So if you walk in here you can see this is the energy recovery ventilator. That's what it looks like.
Okay.
Mine is a brand Venmar from Canada, and it was installed 16 years ago.
It's not
But
that big.
No, it's not that big. Some of them are a little bit bigger than that, depending on how big your house is. But so you see, it's got the fresh air pipes coming in, or I don't know which ones are which, but it brings fresh air in, and then it takes out the stale air. And so they do the air exchange inside that box. And there's also a desiccant wheel in there. So if it's humid air that's coming in the summertime, the desiccant wheel takes some of the humidity out of it as well.
nice.
So you're not overloading your air conditioning.
Yeah.
Yeah.
And that's your hot water heater.
That's my heat pump hot water heater. So this part right up here is the heat pump part, and it has different settings that you can use. You can use all heat pump. You can use hybrid, which is it's pulling the air as much as it can, and if it can't get it up to 100, only set it at 120 degrees. If it can't get it up to 120 degrees, the hybrid kicks in, and a backup coil will help bring it up to temperature. And then it also has a high demand, like if you're having a big bunch of people in and you need hot water all the time. It's got vacation mode on it, so that you can turn it off when you go and leave as well.
How big is it?
40 gallons,
40 gallons?
40 gallons.
Standard, basically.
Standard, yeah. This is what they say. They say it's going to use this many kilowatt hours per year, and this is the estimated yearly energy cost for all our hot water. So this is where the solar hot water tank sat before. And let's see. And this is my radiant heat. That's my what do you call that? Manifold. My manifold with my pipes that go in the floor. So that's all the equipment that it requires.
And that's a little boiler there?
Nope, that is soft water.
Oh,
I have a soft water thing too. This is my tankless hot water heater that runs the floors. So it's all piped, it's separate completely to any other heating system. So it only runs the floors. I can turn it on and off. I can adjust the temperature of the floors. But really I think it's set at 110 degrees. You really don't need a hot. You can turn it up if you want to, but 110 degrees in our floors seems to work just fine and keep the temperature of the house at like 70, 72 degrees, even if that's the only thing that's running. So it does very well. And it's on an outside wall, and it's in the garage because it has a lot of air. You can suck air from the garage, but it's on this outside wall because it's a double wall pipe that vents and also brings in fresh air for combustion. So it's a very expensive pipe, so you try to get them on an outside wall. So. And I have had to replace that already. There are several things that I've had to replace already in 16 years, which unfortunately, this was one of them because those just don't last all that long. So
So did you get 10 years out of it?
Yes, I did get 10 years. I actually got about,
That seems to be the standing order for
I-
appliances these days.
I think I got
10,
about
12 years.
13 or 14 years out of it,
Okay.
actually. I think I only replaced it a couple of years ago.
So this one's more efficient than the other.
This one is more efficient than the other one. You're right. And it's smaller. It takes up, you can see where the other one was installed down here. It was bigger. So, and it had a different sort of thermostat set up on it, but, and this is a Takagi. So my other one was something else.
This looks space age.
That is an electric lawnmower. So my little bit of mowing that I have to do, I have, there's the battery charging right there. Has a little battery. I've had that for 16 years as well, and only had to buy one new battery, and that was just a few years ago too. The first battery for that lasted for 13, 14 years as well. So I'm pretty fortunate there. I was trying to think of what else I've had to have replaced. Well, the hot water tank. So the hot water tank and that, it seems to be water related. Dishwasher I've had to replace. Honestly.
Water and pipes.
Water and pipes, yeah. I was trying to think. Oh, well, okay. So this was a mistake of the installer. I have had to have the interior air handler replaced. My air handler is upstairs in a closet, so it works in conjunction with the outside unit of the heat pump. My heat pump is a Train. It's a 16 SEER, so it's a high rating. And when it goes out, it's going 16 years, and they said it was really good for going on 16 years. When it goes out, I'm going to get a higher efficiency heat pump, highest efficiency that I can get probably. But my inside air handler, they installed it incorrectly when they installed it and caused me problems. So it's sitting on a closet floor, and that is sitting on trusses. And I was trying to think of what happened. They didn't distribute the weight on the trusses properly. And one side of the unit started sagging down like that, but it was the side that it was supposed to be, if anything, tilted like that, so the water ran to the, and I had water leakage. Leaked down into my laundry room, ruined the ceiling in my laundry room, which I haven't fixed, you'll see. But anyway, it took me a long time to have them out for me to convince them that that's what was happening. I said, put a level on that thing and you'll see what's happening. And sure enough, they did, and they pulled it out, and sure enough, it had sagged down on that side, and that's what was causing it. So they pulled up the floor, they put some more reinforcing underneath it, because all that plywood was all wet and saturated, so they pulled that all out, put some more support, put another joist support underneath where it needed to sit, and then replaced the flooring, sealed it all up again, and then reinstalled it. So, at my expense, but because it was already 10 years old when it started doing that. Yeah.
That's too bad.
That's too bad, yeah. I pleaded with them, but it's all right. Everything, I'm very happy with most things, how they performed or lasted, so yeah. In most people's houses, comparatively, I think I'm doing pretty good.
Yeah.
Any other questions?
You were a pioneer then. You were, aren't you?
Mm-hmm. Yes. Maintenance, to be mostly maintenance free too. So I said I have fiber cement siding on the outside of it. I have vinyl soffits. I have aluminum fascias that don't rot. I got a lot of stuff that makes it maintenance free. So, and I have painted the fiber cement on the lower part. I have painted one time, and that was about 3 years ago. So at about 14 years. I decided to repaint the lower half because I could reach it all with just a ladder. I didn't do the upper part yet, so it's still, it's doing good. It's doing great. I would highly recommend fiber cement for durability and maintenance free, holding paint, all that good stuff. It does really well.
That's amazing. Wow, thank you so much. I feel like I've got a college level course and time here.
Well, good. Okay. Well, I'll head over to Vic's house.